Hello everyone, today we're going to talk about simple and compound interest for this week's lesson. So let me talk about simple interest to get started. Here you can see the equation A equals P times 1 plus or minus R to the T power. Let's talk about what each one of these letters mean so you have a little bit better understanding of how to use everything and what to look for. So let's start with A. Here we go. Here's A. I like to think of A as our total amount or quantity, or whatever it is that we're looking for, total amount or quantity. All right, our next letter that we're going to talk about is P for principal. Here we go. Principal is a lot of times our starting quantity, our starting amount. So let me write that down, principal. It's like the beginning quantity, the starting amount, initial deposit, you'll hear a lot of times. And that value will go here for the P in the equation. Next, let's talk about the plus or minus. This is sort of important. If we have, so we'll talk about both of these. We'll bring it down here. If your value is positive, this means it's going to either be increasing, it'll give you some words, in your word problem, you'll have some sort of indication that the value is going to be increasing, your rate is increasing, the amount you owe. There'll be multiple keywords as you read along to know if your rate will be increasing or decreasing. If it's a minus, you would choose minus. If it is decreasing. So again, you look for some keywords throughout your word problem that you read to indicate which one you're going to choose. Next, we're going to have our rate. Rate, this little guy right here. He's our rate. Now, typically, when they give you a rate, it's given to you in percent. You need to understand that you're going to need to change your percent into a decimal. And if you can't remember how to do that, I'll show you real quick that you're going to take whatever the percent is and you're going to divide it by 100, and that will convert it to your decimal value. And you can use that quite often. Some of you might like to move the decimal point to the left 2 times. If you remember how to do that, go for it. If not, use your handy dandy calculator and type it in. Finally, let's talk about time. Time up here on the top, that's your little exponent. This is time. Typically in terms of years, they'll tell you after 8 years, after 7 years, after a certain amount of time has passed, that value will be here in your exponent position. So this is time. And for what we do, typically we are referring to number of years. All right, so hopefully that's a good introduction to simple interest. Next, we're going to talk about compound interest. All right, so we're here with the compounded interest formula. I'm going to talk briefly about the pieces of this that look more familiar to you. I'm not going to spend a lot of time reiterating all that. And then we're going to talk about the obvious differences, which is the letter N, the variable. We'll go into that a little bit more in detail. All right, so A, move over here out of the way. Make sure I have plenty of room. This is our total amount or the ending value that you've received that we're looking for at the end of our problem. So obviously that's our total. Then we have P And we mentioned that before. Our P is our principal. That's the initial deposit, the beginning amount, or the beginning quantity. Initial amount. Okay, so then we have our 1, and then we have plus or minus. Now, the plus or minus, really, you're going to only focus on the plus in this equation. So that's going to give you some kind of indication in the word problem that the values will be increasing. Our next variable is our R, which we've already discussed is the rate. Here again, let me just reiterate that you need to make sure that you are going to change that from a percent to a decimal. Do not forget, that's super important. Now here we have our two variables. You'll notice the letter N is located in two locations. One is in the denominator of the fraction inside the parentheses below the rate, and the other one is in the exponent position next to the T for time. So I'm going to kind of circle both of these in darker purple, and we will discuss those over here. Now this is the big difference because we're talking about compounded interest rates, and when you're reading or looking over your word problems, you'll notice it'll tell you that this particular scenario has a rate that's being compounded, and it'll tell you how often that occurs. So compounded monthly, compounded weekly, compounded annually. There's many different descriptive words that they'll use, and that's where the value of N comes in. So N is the number of times compounded in 1 year. And I'll go into more details on that in just a second on the next slide. Then we have our last variable that we need to talk about again, and that is our time up here on the top in the exponent position as well. You'll notice the T is being multiplied to the N variable. So here we are with time. And typically they'll give that to you in years. Okay, so let's go on to examples of N, that variable that we discussed earlier, the number of times something compounds within a year. So in your word problem that you're reading, it'll probably say compounds blank, some kind of descriptive word that gives you an indication of how often. You may see it say compounds monthly. Okay, well, how often does that occur in a year? How many months are there in a year? Well, there's 12, so we would put 12 for N. 12 would equal N, and we would put that in both locations. Another descriptive word that you might see or hear is annually. And that would be an annually, something that occurs annually occurs once a year. So that would just be a 1, and that's okay. So that would be what N is. You may see the word or hear the word quarterly. How many quarters are there in a year? If we broke it up, just like how many quarters are in a dollar, that would be 4. So 4 quarters in a year. So that's being compounded quarterly. You might see or hear the word semi-annually. They always talk about like semi-annual sales. Everyone does it. They love to advertise that way. So that semi-annually means it's going to occur twice a year. So that would be 2, and that would be your N value. You may even, they may go as far as something that's being compounded weekly. Just to kind of help you out, if you don't remember, there are 52 weeks in a year. So 52 would be our N value. Here we go. Let's get started with our notes. that if you do not have a copy of these are also available online. I've imported them in here to kind of so you can see everything. In addition, I've also have a little calculator that I've recorded, so it'll make it easy for you to see what values I inputted to get my answer. And then notice in the top left-hand corner, I have some helpful hints. Here you can see a copy of the simple interest formula, the compound interest formula, and what each part means. So let's get started with number 1, and we'll kind of break everything down so that we know what is important to us. Here we are with, there are 2,000 deer in a field. The population is increasing at a rate of 1.5% each year. How many deer will there be after 10 years? So I'm going to go through and break this apart. It talks about there are 2,000 deer. So I'm going to go ahead and underline that because that's kind of important. If I look over at my list of descriptors, I would say that's my initial amount. I'm going to go ahead and indicate that that's my P for my principal value I'm going to use later. The population is increasing. Here it is telling you that that rate or the population is going to continue to rise. So when it goes to the plus or minus version of the equation, I'm going to go ahead and put a plus here at a rate of 1.5%. Notice it's in percent. I want to change that to a decimal. So I know this would be my R value, and we'll change that in a second. And then we have to answer the question. It says, how many deer will there be after 10 years? Here we go with the time. That mentions that years, so we're going to use 10. And let's create our equation. Obviously, I don't see any words that mention the word compound, so I know for this one, I am not using my compound interest formula. I will be using the simple interest. As we get started with our formula, but the first thing that we need to do is we need to do something with our rate. Right now, it's currently in the percentage. We need to turn it into a decimal. So let's go ahead and take care of that. We will go over and do 1.5 divided by 100. If you type that in your calculator, it will give you 0.015. I also, kind of old school a little bit. A lot of you remember knowing that you can move the decimal to the left 2 places. So I will show you that as well. If you have 1.5 as a percent, if you move the decimal to the left 2 places, this will be my new point, and I put a 0 in front of the 1, which also gives me my 0.015. Either way will work. Let's go ahead and write our formula down, because that's what it's asking for. It's our equation. So it starts with A, because we don't know what A is. We don't know what our answer is yet. And then it says P would go next. So P up there we indicated would be our starting amount would be 2,000 deer. Then we're going to do open parentheses. Then we do 1. And since we're increasing, we talked about a plus at a rate of 0.015 in decimal form. And then it indicated to us that we needed to do it in 10 years. So notice that will be our exponent value in the top of that parentheses. All right, so let's take a look. All you have to do at this point is plug it into a calculator. If you have the Chromebooks for school that were issued, if you go down, you can now type in your search bar for TI. It will now have a calculator that's been pushed out to you. If not, I'm going to create a link, and we'll talk to you more about how to use Desmos on your on your laptop or what other device that you're using. So I'm going to go ahead and push play here, and you can see the values being entered in the calculator, and we can get our answer. Notice it says round answer to the nearest. That should say number of deer. I think it's fixed. There we go. So here's our number. I put in 2,000 parentheses, put my information just like I wrote it in my equation, and our number is 2321.08165. However, I want you to round to the nearest number of deer, a whole deer. So that would be 2,321. Remember, you're looking to the right. And since it's a 0, we're just going to round down 20. So you have 2,321 deer. Okay, continuing to number 2 of our notes. During your COVID-19 lockdown, you decided to take a tennis ball outside and see how high it will bounce if you were to drop it from a 70-foot ladder. You notice the ball takes a sequence of bounces that are half as high as the preceding one. How high will it bounce after it hits the surface for the 6th time? So we need to create our equation. Did you notice in there it never said the word compound? So we will not be using our compound interest formula, so we can just mark that off. And we need to go back in and indicate what values are going to represent what variables. So going back in, it says the ball was dropped from a ladder that was 70 feet high. So that would be our initial value. So we'll say that's our P. And then we need to go on. It says, you notice the ball takes a sequence of bounces that are half as high. So half of something, it would be 1/2, or in a decimal form, we could say that would be 0.5. That's the rate of which it's bouncing. Notice this is not a percent. It's already done as a decimal for us. How high will it bounce after it hits the surface for the 6th time? That would be our time indicator. Notice it wasn't years this time. A lot of times it is. However, this is just the 6th time it occurred. We want to see what the value is going to give us. So here we go. Let's create our equation. We have A equals. Our P was 70 for our initial height. Open parentheses 1. Again, on this one, let's talk about whether or not we need to use plus or minus. If something's bouncing, we want to see that it's going to bounce half as high as it did previously. That means our height is going down. It's decreasing. So we're going to use minus this time. And then we're going to have our rate of 0.5. Close parentheses, and then our time we indicated was 6 as our exponent. Again, I'm going to go ahead and let you see what it looks like when we type it in the calculator. And that gives us our total. It says that it's at 1.09375. Well, that's a little too crazy long for me. I want us to round to the nearest hundredth. Remember, the nearest hundredth is 2 decimal places. So I need to look at here. So I need to look to the right. It's a 3. That's below 5. So I'm going to leave it at 1.09 feet. There we go. That's number 2. Okay, so let's get started with number 3. Your first credit card charges you 19% annual interest compounded monthly. If you purchase a new flat screen television worth $2,400, how much would you actually pay for the television at the end of 7 years? So let's go back and indicate which equation we want to use. I remember reading the words compounded monthly. So that would give me an indication I want to use our compound formula that has the word compound in it. So I'm going to mark off the other one, and we're going to focus on this second equation. So 19%, this would be our rate, and we'll work on changing that in a second. It says it's being compounded monthly, so that is going to be referring to our N. Monthly is, remember, it's the number of times it occurs in a year, so months would equal 12. There's 12 months in a year. If you purchase a new flat screen TV worth $2,400 would be our principal, our initial investment into the TV. How much would you actually pay for the television at the end of 7 years? And that would be our time. So let's go ahead and change our percent. 19 divided by 100 equals 0.19 for our rate. And let's go ahead and plug everything into our equation. We know it's going to start with A equals. Our principal amount was $2,400. Open parentheses 1. And since again this is increasing over time, we're going to put a plus because the interest rate is increasing. And then this is the one where you have to use your fraction. So you're going to rate is going to go in the numerator, so 0.19 over the number of times it compounds. In this case is 12. Close parentheses, and then my exponent value, you will have 12 times your time, which was 7. And you can put those also in parentheses if you'd like. Depends on how you enter in your calculator, whatever you feel comfortable with. Okay, so let's see what that will give us in our calculator. If you can't remember, we use alpha y equals as a shortcut to make that fraction in our calculator. And I know if you use the TI calculator that's been pushed out to you on the school Chromebooks, it has that function as well. All right, so here we go. Our total came out to 8980.444757. This is referring to money, so we want to make sure we round it properly. In this particular case, it says round the answer to the nearest dollar. So I would assume to the nearest whole dollar is what we're looking for. And if that's the case, obviously we would look over to the 4. It's below 5, so we're just going to leave it at $8,980. Here we are with number 4. This is our last problem on the notes. It's a little bit different the way it's set up. It's kind of a multi-step problem, so we're going to kind of step through this as simple as possible. Let me read the problem to you. It says, you have been watching the value of land over the last several years and have noticed the value is steadily increasing by a rate of 9%. You decide to buy acreage for a total of $3,750. What will the land be worth when you sell in 8 years? Predict, and then it asks you to predict how long it will take to triple the initial value of the property. So we're going to need to go through and create our initial equation because we need to answer the first question about how much will the land be worth in 8 years. So we know 8 years is going to be represent our time. We are not using compound formula here, so we're going to mark that one off. And then we have a rate, it looks like a rate of 9%. We're going to buy our acreage for $3,750, so that'll be our P. And since we're talking about increasing, that'll be our plus. So let's go ahead and create our equation and change our rate. So I know our rate, so 9% divided by 100 would equal 0.09 for our rate. So we have our equation is A equals P is 3750, open parentheses 1 plus our rate of 0.09, close parentheses, and time was 8 here. So if we plug that into our calculator, which I've done for you, you can see what the total is. So that gives us, rounded to the nearest dollar, $7,472. And then we go to the next problem. It says tripled value of the land. So we need to answer the next question. It says predict how long it will take to triple the initial value of the property. Well, if we don't know what that value tripled is, we need to figure that out as well. So we're going to need to take the initial value of $3,750, multiply it by 3, and come up with that value as well. So we're going to go ahead and continue so you can see that. I plugged it in the calculator as well. So that gives us, what, $11,250. So $11,250 is the total value of the land tripled from the initial value. Okay, so here on the right of the word problem, you can see a graph that I've put on here to kind of represent time along the bottom. So your x-axis would indicate time. Your y value, so this is x, make sure we understand, this is our y-axis, and that is representing your value, your dollar amount. Okay, so for the next question, it asks how long will it take to triple. It's asking us for a length of time. Currently, we don't know, and that's what obviously that's why we're looking to find time. Earlier, we gave you a value. We gave you 8 years, so it was very easy to plug into your calculator and hit enter and go about your business and find the total. This time, I'm going to show you a way to do it when we don't have the same capabilities of solving for time in our exponent location. So you're going to create two equations. You're going to create the first equation of A equals... And actually, let me go back because I want you to, you're going to actually, when you go to the calculator in Desmos, you'll enter it as y equals. So I'm going to make sure we put y equals, and then you're going to replicate that very first equation that we created at the beginning with the 8 for the exponent, except for instead of 8, we're looking for an unknown amount of time. So we're going to put x in that location. And we know what our goal is. We need to know how long it's going to take to get to 11,250. That's our tripled value. So we're gonna create a second equation, which is going to be y equals 11,250, and we're gonna put both of these equations into Desmos, and where they intersect will be our location of time. Now, it will give you an exact time. All we're asking you to do in this problem is round to the nearest year. So I'm going to show you, I'm going to kind of make it a little bit larger. I'm going to see if I can make this a little bit bigger for you so that you can see what I've done. I will go into more details later about how to use Desmos, but you can kind of see the buttons I've done to create this answer. I've gone in, I put y equals, and I'm going to type out the first equation exactly like I did on the notes. And here you go. There we put the x for the exponent because that's what we're looking for. We're looking for time. And then our other equation is the y equals 11,250. Now on the screen currently, you can't see what's happening. So you can pinch it and zoom out. You can see the red line, or you can go over to the wrench on the far right and you can change your y-axis values to meet the needs of your window. And I've done a screenshot. So we're going to go from -500 to 15,000. I'm going to count by 1,000. That's your step. That's what that means. And then I'm going to go to the x-axis. I'm going to change it to -5 because I want you to be able to at least see the x-axis, and then change that value to 15 or I think 20. Yeah, change it to 20, and we're going to step or count by 2s. And then move that out of the way, and you can kind of see where that red line is your first equation, that blue line was the second. And if you just, with your finger, you can drag it around. And if you just touch that intersection, you can see the actual location right there. Here we go. Oops. You can see the location of that coordinate. So here we are. Your x value, your y value. X is 12.748. Your y was 11,250, which was our land tripled. So the amount of time, or the amount of years it took, was 12.748. I just need you to round to the nearest year. Obviously, we would round up, and that would give us our 13 years. So we had 13 years. I'm going to do approximately. Before we could triple, we'd have to own it 13 years to get our value tripled. So there you go. And have fun with your assignment. Hopefully everything is explained well enough. If not, I'm sure you can reach out to all your teachers and get clarification. Thanks.